Hi folks, in this video we're going to talk about different types of images, often referred to as maps, that you will see in a 3D texture and material workflow. Often the materials on a 3D model will combine multiple images or bitmaps to define a single surface. We need to understand what these bitmap types are so that we may utilize them very quickly when another team member gives them to us or we download a package of images for a material. But we also need to understand how we can create them ourselves in our own workflow to make unique looking designs. The first image type is the most common, and it is just the color information. It is commonly referred to as the diffuse or base color or alembic. This is typically a full color image used to represent the surface texture, usually without lighting or shadows or distortions. Sometimes it will have some shadow information if it was created from a photograph, but it is meant to be a flat image. The next map you will commonly see is a normal map. This image is usually identified by its blue tone, and this is a full color image that represents the direction the light will hit the surface of the object. These normal maps started as very common in games because the graphics cards used them to efficiently define surface undulation. This is a full color image that represents the direction the light will hit the surface of the object. If a red, a green, and a blue light were shined at the surface from different angles, this would be the resulting image. The first black and white or grayscale image that we see used for materials is a bump or displacement map. In this map, white typically represents higher surface, while black represents the lower surface. This allows the software to create an undulating surface at the material level. Bump maps are a kind of cheat because as the object curves around away from the camera, we start to see that the geometry is not actually being deformed. So here we see the sphere is still perfectly smooth on the edge. This is the opposite of a displacement map, which actually moves the geometry around at render time. This typically requires much higher polygon counts and is slower to display or render. Sometimes the object is subdivided many times before it's rendered or displayed. Displacement maps used to be very rare in games, but are becoming more commonplace to represent organic materials as graphics cards become more capable of handling them. Bump maps, on the other hand, are being phased out in most workflows in exchange for normal maps, which can convey light direction bounces more accurately. Other maps you will see are common grayscale images like a roughness map. You will see various black and white images used to define a material's reflection properties. This might be roughness, glossiness, specular, or reflection maps. These maps dictate how light bounces off the surface and how much it scatters as it bounces. While these maps do vary for their different usages, white typically represents the most scattering of light, while black represents the least scattering of light. As you can see here, the differences can be very subtle between these effects. The next grayscale map is usually the metalness or metallic map. A metalness map is used to determine how conductive a surface is, which affects how directly the light bounces off the surface, making it look more metallic. This is commonly used in conjunction or opposed to a roughness map to create a range of surfaces and reflection types. So roughness and metalness usually go hand in hand in a PBR or physically based rendering workflow. The next grayscale map is an ambient occlusion or AO map. Ambient occlusion maps allow you to add false shadows in the interior small corners of your material. These are often used to save time in rendering because it might take too long for a scene to calculate the light bounces to all these tiny spaces. These maps can not only boost the contrast of your models, but they can also be used to drive grunge or weathering effects as well. A material doesn't need to contain all of these maps. In fact, you will rarely find a material that has all of these. However, when combined in a material workflow, these different image types really help convey a sense of specificity and realism in our materials. Let's briefly talk about additional maps that you're going to see in your travels as a 3D artist. You will see curvature maps that are colored maps that indicate how convex or concave the surface of a model is. In Substance Painter, for instance, you can bake this map when you import your 3D model and apply filters to just these portions of the model. There are vector displacement maps that are similar to a black and white displacement map, but they are full color, so they can create 3D geometry that has overhangs. There are RGB mask maps or splat maps that are used typically to pull either a red, green, or blue channel from a single image to use instead of 3 black and white images. When you see a texture that has a crazy color like this is typically what it's used for. These are MIP maps. Occasionally on the same image you will see these blurred, resized versions of the same tile and texture. Game engines will swap the display of these as the object goes into the distance, both to reduce the load on the graphics engine, but also to blur the texture as it goes into the distance, creating a more realistic scene. This is now most commonly done automatically inside the game engine itself, so you probably won't need to create them manually anymore, but there are some projects where it's useful to control this. Texture atlases contain a large amount of patterns and textures, both tiling and non-tiling, that will be used across an entire game level. This allows the game to load one map and use it for many objects. This is more common in mobile games where loading a lot of texture maps can slow down the game. It's, however, also becoming less common as devices become more advanced, but it can save some time devoted to managing hundreds of texture files. Trim sheets are texture maps where sections are blocked out for tiling on different parts of an object. This is used a lot for environment design, where decorative elements and surfaces can be placed on different polygons in the model. This is typically performed on the UV layout, where the polygons are moved onto the image to align with the details of the trim. This method allows for very fast prototyping in a game design workflow. These are sprite sheets, where a character or object will be broken into multiple poses on a single image. The game engine will alter the placement coordinates on the object according to the animation. This technique was not only popular for old games like Metroid and Mario, but you will also see this used in newer hybrid 2D, 3D games like Cuphead. Okay, so that's a brief intro to some of the image types you will see in creating materials and textures for your 3D objects. The methods that we use for creating 3D objects are constantly changing, and artists and programmers are creating new ways that we can utilize 2D images to represent 3D surfaces. So many new types of images will emerge, but it's important to have a firm understanding of how to manipulate these images in your workflow. All right. Work well, stay inspired, and I'll see you next time.